Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 930, binary subarrays with sum. This is a medium difficulty Leetcode problem, and the problem description tells us that given a binary array nums and an integer goal, we want to return the number of non-empty subarrays with a sum goal. And a subarray, we're told, is a contiguous part of the array. And we're given an example over here where we have a goal of 2 and we're given an input array nums and we return 2 because there are 4 subarrays and they're bolded over here that are that basically equal the integer goal, and so the output that we return is 4 because we have 4 subarrays which meet this condition. So if you guess this is a sliding window problem, you would be correct in that this is a sliding window technique that we need to implement to solve this problem, but it's not an orthodox textbook sliding window problem. And I'm going to show you why. So let's say, for example, we're looking at this problem over here. And this is great because, we want to count how many subarrays are equal to 2. And so, we do 101, and then, let's say we get to over here and we've kind of done a couple of iterations, or, our window is basically down here. So we have this window over here where we have 0, 1, 0, and 1, and that equals 2, which is fine. But we are only shrinking our subarray. We're only shrinking our window when the goal is greater than 2. This is what we would do in a normal sliding window problem. In a classic sliding window problem, we'd shrink our window when the goal is greater than 2. But that's not the case because it's prefaced by a 0, and so there's no reason for us to carry on shrinking. And so we would miss out on this subarray here, 101. We would only consider 0, 1, 0, 1, but we would never actually shrink our window and find out that there is another subarray 101 that we've missed. And that is a bit of a problem, because of course that's not optimal, and it's really the zeros over here that messes this up for us. So how can we actually mitigate and solve this? And the way we can actually solve this is, instead of saying let's look for all of the subarrays which equal to 2, let's find all subarrays which are less than or equal to 2. So we find all subarrays which are less than or equal to 2. This will consider subarrays like 1, 0, 1. And then what we do is, how do we find out how many equal to 2? Not just less than or equal to 2. What we do, we'll create a helper function with our goal, and we'll basically find the number, so the count of goal minus the count of goal minus 1, subtracting all the subarrays which are less than or equal to goal minus 1, will basically give us the number of subarrays which equal to our goal. So that's the intuition behind solving this problem. It's putting our sliding window in a helper function that I've denoted as C over here, and then returning the helper of goal minus the result we get from passing in goal minus 1. So let's actually get to coding this up, and it'll make more sense once we solve this solution and actually write the code. But I would definitely recommend kind of walking through the example yourself and seeing why a classic sliding window problem wouldn't actually work, because it did catch me up as well. It does look like an orthodox sliding window problem until you actually look at the edge cases and why it isn't. So the first thing we want to actually do is create our helper function. We want to pass in x, which is going to be the goal, and we want to say if Actually, let's set up some variables. So we're going to say result is equal to 0, count, which is going to be the accumulation that we've had so far. So we'll just call this ACC, it's nicer. So this is going to be what we accumulate in our window, and then we're going to have our left pointer. And I should set that to 0, and then we're going to have our right pointer from our range function, and we're going to pass in the length of nums. And what's going to happen here is we want to increment our accumulator by 1 every time. And while our accumulator is greater than x, we want to say accumulator minus equals 1. And we want to also actually minus equal nums L, and this should be nums R. And then we want to increment our left pointer by 1. And if we were sticking to a classic sliding window problem, we say if target is equal to 2, then we will increment our result, but we're going to increment our result regardless, because we're going to factor in all subarrays which equal to the condition or pass the condition of being less than or equal to the goal. So the result is going to be equal to, the result is going to be, we're going to increment our result by the size of our window so that we can get all the subarrays in our window. And then we just want to return our result. So we want to return our result. And so now we've got our helper function. We can simply say return helper goal minus, and let's pass in goal minus 1. So this will give us all of the subarrays which are less than or equal to, let's say our goal is 2, and then we'll get all of the subarrays which are less than or equal to 1, and then we can basically subtract the results which are less than or equal to goal minus 1, and which will give us all of the subarrays which equal to our goal. So that's the intuition behind this kind of solution. Now let's submit our code, and we get a out of range error. Okay, plus equals nums R. Okay, there is an edge case here. We need to keep in mind, if we had a negative number, and this is actually what I was supposed to put in initially, but then I just skipped over it. If x is less than 0, we want to just return 0, because let's say our goal is 0 and then we had a negative number, that would just mess up all our logic over here. So we want to just check if x is less than 0 and then just return 0. And that actually now passes all 61 test cases. So the time complexity for this problem, guys, is going to be big O of what? Big O of n. It's 2 passes, but it's simplified to big O of n. And then the space complexity is simply constant, so it's big O of 1. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.